Yeah, we'll talk about the electromagnetic wave and the energy transport, and also the Poynting vector, which is actually the direction of the electromagnetic wave. And the later part will talk about something called the radiance pressure, which is something like the particle characteristic of the photon, and also the polarization. Actually, the polarization is something related to the quantum theory, and also we'll talk about refraction. I suppose you should have learned it in high school, and total internal refraction, something like that. Okay, so when we talk about electromagnetic wave from another point of view, so we have the Bible. The first chapter in the Bible is called the Genesis 创世纪的第一章1到3节是起初神創造天地，地是空虛混沌，淵面黑暗，神的靈運行在水面上，神說要有光，就有了光。Okay, so actually this is in the Christian point of view, we say that so the God tried to create the light at the very beginning. At the very beginning, there is nothing in the universe. Yeah, before it create light, actually there are some waters. And also in Christianity point of view, they thought the waters are somehow evil. Yeah, somehow evil. Yeah, the spirit of God hovering over the waters, and so let there be light. Okay, so here. So here is about the Maxwell rainbow. I suppose I have skipped this part in chapter 21, so I can talk about it here. Okay, so for the wave, we have generally two variables to talk about it. So it is like C equals F lambda. F is called the frequency, lambda is the wavelength. So this is the frequency, this is a wavelength. So when you learn signal and system, you know frequency domain. So frequency times the wavelength will be a constant, which is the speed of light, speed of the wave, and of course here we talk about the electromagnetic wave. So this one is the speed of light. So as I mentioned, it is about 3 times 10 to the 8th meter per second, or 2.998 times 10 to the 8th power meter per second. Okay, so in that case, speed of light is a constant in inertial reference frame, no matter what is the constant speed of the reference frame. The speed of light are a constant. So it means that the frequency and the wavelength are inversely proportional to each other. If the frequency is larger, then the wavelength is shorter. If the frequency is lower, then the wavelength is longer. So here, this axis is frequency, this is wavelength. So we have high frequency on the right side and the long wavelength on the left side. So here you can see the long wave, radio wave. So this is something like 10 to the 8th power. 10 to the 8th power, which is around 100 megahertz. So for the TDM in Macau, it is 100.7 megahertz. If you if you know the TDM, and usually the radio frequency is around 100 megahertz, or maybe 90 something or 100 something. So we use this rather long wavelength frequency to transmit signal in a long distance. So for this part, roughly more than 10 to the 9th power, which is around gigahertz. So we will use it for we'll use it for wireless communication, something like 2G, 3G, 4G, 5G. 5G maybe still using this part, but also using the 30 gigahertz, something like here, which is called a millimeter wave, because the wavelength is in the order of a millimeter. Okay, so you can see here, around this part, 10 to the minus third power meter is around millimeter. So around this part, they will try to call it the millimeter wave. And here, for 2G, 3G, 4G, we will use this part. And for the Wi-Fi, we have 2.45 gigahertz or the 5 gigahertz. So when you set up a router, usually it will usually generate in 2.4 gigahertz or 5 gigahertz. And some people don't know what is 5G, 5 gigahertz, and what is 5G in the RAN communication. So actually, that 5G is the short term for the fifth generation of communication. 第五代的通讯. Here it refers to the 5 gigahertz. So they are totally different. And of course, if you like to have a faster transmission rate, then you may seek for 5 gigahertz. And however, the 5 gigahertz will attenuate faster. So if you are not directly facing the router, then your signal might be weak, and in that case, it might be slow. So if you are not facing the router directly, then you may try to seek for the 2.4 gigahertz. Then it may be more reliable. So this is so-called the RF frequency, and even for higher, we can see this is the infrared, and this is the visible light. The visible light. So the visible light is of course one type of electromagnetic wave, and so we can see the rainbow here, but actually lower than this part, if the frequency lower than this part, it is the infrared, the 红外线. This part is the ultraviolet, 紫外线. So for even higher than the ultraviolet, this is X-ray. So when you try to see your lung, you need to take the X-ray. And even for higher frequency, we have the gamma ray. And yeah, in chapter 38, we know that E equals HF. So for a photon energy, it is proportional to the frequency multiplied by the Planck constant. I just mentioned it sometime in the first hour, which means that if the frequency is higher, the energy of the photon is also higher. So in that case, for high frequency, it also means high energy. So that the gamma ray are the highest type energy of the EM wave, and for those type, the energy is rather low for a single photon. Okay, so let me stop here today and